Hey guys, it's Mr. Nakmi here. Today we're going to be continuing with 6.3 with another example of how to calculate a confidence interval for a population proportion. Right? We did this last time and we're just going to do another example of it, okay? So if you remember from last time, to calculate a population proportion, right, a confidence interval for that is simply just your p hat minus your margin of error, and that has to be less than what we're thinking the proportion is for the population, minus p hat, which is the point estimate for the population proportion, right? Or in other words, the sample proportion, plus your margin of error. And your margin of error, to calculate that, right, is just going to be equal to z critical, right? Because remember, since this is a proportion, right, we're going to be using the normal distribution, an approximation of the normal distribution for a binomial, right? It's either yes or no answer for this one. So we're going to be using the z critical for it, multiplied with the square root of p hat, which is what we find from the sample, times q hat, which is the probability of failure from the sample, divided by n. Okay, so those are all the things we need. Okay, so let's take a look at this problem right here. The graph shown below is a survey of 900 US adults. Construct a 99% confidence interval for the proportion of adults who think that teenagers are the more dangerous driver. Right, so 99% confidence level, right, is telling me that my confidence level is equal to 0.99, and I'm going to look that up to figure out if I can calculate my z critical, right? What is that going to equal to? But before I even do that, I need to double check that my NP and my n times p is greater than or equal to 5, and my n times q, I should say p hat and q hat, of course, is greater than or equal to 5, right? My P in this case, probability of success, is what we're looking at, is that the teenagers are more dangerous drivers. So that means the percentage we're looking at here is 63%. Right, that's going to be my P hat. My N is how many people I surveyed, which is 900. So I just need to check, is 900 times 0.63 greater than or equal to 5? Right, and I just plug that in my calculator. 900, let's turn that on first. Come on. Yeah, that's right. 900 times 0.63, failing here, 900 times 0.63, that is equal to, 567. That is definitely more than 5. And then we might as well just do it for q hat as well. Q hat is going to be 1 minus 63%. Let's put that in first. Let's write that out here just so we have everything organized, right? So p hat is equal to 63%. That is terrible. 63%. And then we have q hat, which is 1 minus that, which is going to give me 37%. Right, and I just plug that in to double check, is that times 900 going to be greater than or equal to 5? And I multiply that out right here, and yes, that is bigger than 5. Right, so both of them are larger than 5. I'll write that out. This checks out based off the calculator. So I have my p hat, I have my q hat, my n is also given to me as 900, right? And all I need now to calculate my margin of error is my z critical. And my z critical is going to be an approximation of the normal distribution, which is right here on this table. And I'm looking at 99% this time, which is this one right here. And they already have it for me. My z critical is 2.575, right? Remember, these are usually they'll ask us in a nice like level of confidence that we can use this off this table. But if not, you should know how to find it by looking at the tails based off of what needs to be in the center, right? If it's 95%, it splits it like so, and you need to know how to look it up on the table, right? So anyways, this one, 2.575 is what we're going to be using. 2.575. So z critical is equal to 2.575. So to calculate my margin of error, right, we're just going to plug these numbers into that equation. So my z critical is 2.575, and this is going to be multiplying with the square root of p hat, which is 0.63, times q hat, which is 0.37, and this is all being divided by 900. Okay, so we just plug this into the calculator, and we're going to get, let's go ahead and plug that in, 2.575, right, multiplied with the square root of 0.63 times 0.37, and this is all being divided by 900. And I get here a margin of error of 0.041. 0.041. Let's go. Yeah, let's go. I'm gonna go ahead and write that out. 0.041. Might as well just get to the fourth decimal place, and that's gonna be a 4. Right. So that's my margin of error. I got 2 decimal places there. Boop. All right. And I just simply add that and subtract that to my p-hat, and that'll give me my margin of my confidence interval, right? So my p-hat is 0.63, so it's going to be 0.63 minus 0.0414. That's going to be my lower end, which is going to, and then that's going to be less than p, which is going to be less than 0.63 plus 0.0414. Whoops, ran out of space there. So this is going to be 0.63 minus 0.0414, which is 0.58. What was that? 86. Less than p, less than, same entry, except it's going to be a plus sign this time. 0.63 plus 0.0414, which is going to give me 0.6714. 0.6714, and there we go. That's it. That's another example of it. Right? It's not too bad. It's just like what we've been doing before, except now our answers come out in percentages, right? I'm leaving my answers as a decimal for the percent form, right? This is one I want you guys to try and submit it onto Canvas for this one. Right. In the survey above, I need you to calculate a confidence interval for the proportion of adults who think that people over 75 are the more dangerous drivers. And I kind of did not finish my sentence there. So when you guys do this, you're going to do it for the other example. I want you to find the margin of error for me. I'm either going to ask you for the lower bound or the upper bound. I've noticed that Canvas is acting kind of weird for you to type in those fill in the blanks answers. So it'll just be one or the other. All right, so make sure you read the problem and check to see which one is blank, and you just fill out for that one, okay? And with that, that's pretty much it for today, guys. We're going to be wrapping this up next time. There's only one more thing left, which is how to calculate the minimum sample size. We'll do that next time, all right? All right, I'll talk to you guys later.